Hi friends, welcome to my video channel COVID-19 Techno Class. In this video, I will cover the topics on satellite launching nations, remote sensing sensors, and different types of satellite data based on their sensors. This video lecture is made for degree students with arts background and not having any technical knowledge. So I am making this lecture as simple as possible, ignoring some critical technical terms and concepts. As you are aware that there are various satellites in space and they are launched by different nations for particular purposes like communications, earth observations, navigations, space research, etc. Therefore, their orbits, sensors, and types of data they transmit varies from mission to mission. So, as I said, we will be discussing here only those remote sensing sensors and the data they transmit. But before that, let us see some of the top nations in launching space satellites. USA with 830 launches tops the list, followed by China with 280 satellites. Then next comes Russia with 147 satellites, Japan 75 satellites, and UK and India with 54 each satellites. Some of the most popular Earth observation satellites of these nations are as discussed below. United States has the most commonly used satellites called Landsat series, followed by some high-resolution satellites like Early Bird, Iconos, QuickBird, and OddView. And Canada with RadarSat series. In Europe, Spot series of France is another very popular series, followed by ERS and Envisat series of European Space Agency, called ESA in short. Euro series for Israel, Middle East, is also widely used. And from Asia, India and Japan has the most widely used remote sensing satellites. IRS series and Cartosat series of India has very wide applications in remote sensing, and we shall be discussing them one by one in details. Among all the satellite series, Landsat series is most popular among academicians because they are most widely available and most importantly, they are fully downloadable. Besides that, it gives the earliest dataset for Earth observations since 1972, the time when it was launched. The first three sets of Landsat series, that is Landsat 1, 2, and 3, has multispectral scanner sensor or called MSS with four band, starting with green band followed by red band and two bands of near infrared range. This satellite series has 80-meter ground resolutions and 185 kilometer SWAT, that is the ground area covered along its path that it's travel. Landsat 4 launched in 1983 used sensor called Landsat Thematic Mapper or Landsat TM with 7 spectral band starting with blue band followed by green, red, near infrared, two regions of short-wave infrared and one regions of thermal infrared. It has a ground resolution of 30 meter and a SWAT is 185 kilometer. Lancet 6 failed after it was launched in 1993, and Lancet 7, launched in 1999, has almost the same features as Lancet 4 and 5, but one additional 15-meter panchromatic camera was added to Lancet 7. Lancet 8, also termed as Lancet Data Continuity Mission or LDCM, launched in February 2013, has OLI or Operational Lens Imager and Thermal Infrared Sensor or TIRS in short on board. Besides that, USA has satellites that provide very high resolution images. For example, Early Bird, launched in 1998, has onboard 3-meter panchromatic cameras and 15-meter multispectral scanner images. Iconos 1 and 2, launched in 1999, has 1-meter spatial resolution image. QuickBird 1 has less than 1 meter, that is zero point 0.6 meter spatial resolutions, and OrbView 1, 2, and 3, 4 series, launched between 1995 to 2001, has 1 meter spectral resolution. Next is Spot series by France. Starting from 1986 till 2014, various Spot series satellites like Spot 1, 2, 3 till 7 has been successively giving multispectral images starting from 20-meter to 6-meter spatial resolution and using 3 to 4 band, and from 10-meter pan image to 1.5-meter single band pan images. Next, we need to discuss in detail is the Indian Remote Sensing Satellite Series and Cartosat series of India. It's an indigenous program which aims for working in the field of water resources, agriculture, forestry and geology. It has a long history and successive achievement from 1 kilometer spatial resolutions to 1 meter spatial resolution, and a repeativity period starting from 24 days to every 30 minutes per day. The IRS series was launched from 1988 and is a continued mission. The first IRS-1A was launched in 1988 and IRS-1B in 1991. The boat had an orbital plane of 904 km above the Earth's surface. They are sun-synchronous or polar orbital satellites that crosses the equator at 10:30 a.m. daily. They had a repetition period of 22 days and the sensor used in them were LIS 1 and LIS 2. Here LIS stands for Linear Imaging Self-Scanning System. IRS-1C and 1D was launched in 1995 and 1997 respectively, with orbital height of 817 km and equator crossing at 10:30 am and a repetition period of 24 days for IRS-1C and 5 days for IRS-1D. They used LIS-3 sensor with pan and wide field sensors or WIF sensors on board. Next is the OceanSat series called IRS-PR, launched in 1999 with 720 km orbital height and equator crossing at 12 noon and repetition period of 2 days. The sensors used on them are OCM or Ocean Color Monitor using MSMR or multi-frequency scanning microwave radiometric sensor. Another very important IRS series is ResourceSat 1, or called IRS-P6, which is launched in 2003. The sensor on board is LIS4 along with LIS3 and advanced wide field sensor, or in short called AVIF. IRS-P5 and IRS-P8 are Cartosat series, and their orbital plane is below 650 km using single band panchromatic sensor that gives very high resolutions in black and white satellite images. And one more OceanSat 2 was launched in 2009 using Ocean Color Monitor Scanner. Next very important point of discussion is the sensors used in IRIS satellite series and their resolutions. Here list 1 had a ground spatial resolutions of 73 meter and a radiometric resolutions of 7 bit. I would like to mention here that there are 4 types of resolutions in remote sensing systems, and I will make a separate video lecture on this in detail. List 2 had a spatial resolutions of 36 meter and 7 bit radiometric resolution using 4 band and a SWAT of 74 kilometer. List 3 has 23 meter spatial resolutions with 7 bit data using 4 band, that is 2, 3, 4 and 5. Here blue band is not used. 2 stands for green band, 3 stands for red band, and 4 and 5 stands for near infrared rays. Pan sensor has 5.8 meter spatial resolution using single band, that is panchromatic camera, and has a black and white satellite images. Wide field sensors or WIF and AVIF, that is advanced wide field sensor, use large spatial resolutions, that is around 188 meter, because they want to study the global ocean condition, and their SWAT is also very high because they have to cover the entire ocean in short span of time. So this is all I have for today. Thank you for watching.